I would say the big story today is this collision of air masses here in Texas, Oklahoma, Arkansas, Louisiana. So the dissipation of these thunderstorms and their outflow boundaries can create another thunderstorm in and of itself, which is why we don't want to thread the needle. Hey there, welcome back to AeroSafe. Today is May 5th. It's 10:30 Eastern Time and 14:30 Zulu. Welcome back to AeroSafe, where we do a weather analysis from the perspective of general aviation pilots. Some of us may be VFR only, some of us may have our instrument rating, but in any case, generally speaking, we're looking at those of us who are flying light piston aircraft. We maybe don't have the ability to go over the weather. There's some weather we certainly don't want to go through, and we not certified for flight into known icing conditions. Here on AeroSafe, we look at the weather across the country from that perspective. So we look at areas of VFR weather, areas of IFR weather, potential hazards that exist within both of those areas. We'll use the AeroSafe Weather Brief Checklist, accessible from gilbertaviation.com. This is a tool I made and developed for you all for free to use as a way to make sure that you're covering all of the knowledge items and pre-flight action items necessary to safely complete a flight. If the shot gets smoky, it's because got a brisket rolling. So we use the Leidos website, 1-800-weatherbrief.com, to do this weather briefing. So using the AeroSafe Weather Brief Checklist, we're going to start with the surface analysis. The surface analysis gives us an idea of the current fronts and pressure systems across the country. Over in the East Coast, we've got a long trough that descends right along the northern border. A trough is an elongated area of low pressure, so that means that air is rising. And we should remember that lifting action is one of the necessary ingredients, not just for cloud formation, but also for convective activity. There is a stationary front that swoops down from the Great Lakes over bottom of it's up to Georgia, peters off in Pennsylvania there, and we've got some low pressure systems along that front as well. Looks like that's producing some cloud coverage and some precipitation. As we move westerly, up in Canada, we've got a low pressure system, and down from that extends a cold front, low pressure again over the Great Lakes, and then cold front down along kind of central eastern US. We've got this cold front that extends from Canada all the way through Texas. There's a lot of cool air that has pushed its way down from Canada, and that's meeting with some really warm, moist air from the Gulf here. Where we see that collision going on and these low pressure systems over Texas, Oklahoma, and Arkansas, we're seeing a lot of precipitation, a lot of storms, and we've seen a lot of convective activity over the last couple of days associated with this kind of weather pattern, and some tornadic activity as well. From there, we've got a little mix of pressure systems over the four corners and a stationary front. There is a low system over Utah here. Extending from that are several different types of pressure systems. We've got a frontalysis here. A frontalysis is a weakening front. That's indicated by the breaks between the front depiction here. Over Idaho into Wyoming, we see a short occluded front. So that's where that faster moving cold front catches up with a slower moving warm front, and then we have three different air masses there that are mixing. And we see the result of that is some precipitation here. Where it's cold enough, it's also some frozen or mix of precipitation. We've got a cold front that extends down through Southern California and Nevada there, and those low pressure systems up over Idaho have a trough extending from them. I would say the big story today is this collision of air masses here in Texas, Oklahoma, Arkansas, Louisiana. That is not only weather that I wouldn't want to fly in, but it's going to be weather that could cause harm to life or property on the ground. That's the surface analysis. We're going to move on to the Sigmets and airmets. And we will look at Sigmets first. So this is telling the same story that we talked about. The gray areas are outlooks. So the models that the meteorologists use show there's potential for convective activity or thunderstorms. There's a sufficient moisture, there is lifting action, and an unstable lapse rate. There's a good chance that there's going to be convective activity here, We're not exactly sure where yet. However, we do have not just convective outlooks, but actual convective sigmets where they say this is very severe convective activity going on right now. And so we see that north of Oklahoma into Kansas. Area of embedded thunderstorms moving from the south at 15 knots. Tops are to flight level 400, 40,000 feet. Of course, as piston pilots, we don't have the ability to go above that. We also don't want to go through it. Further, traditional standard and practice from the FAA is that we should remain at least 20 miles away from a thunderstorm. The best practice to follow would be that for every 10,000 feet of vertical development, we remain at least 10 miles away from a thunderstorm. So it's important to know the tops of the thunderstorm. Like this one, it goes up to 40,000 feet. We would want to be at least 40 miles away from that. The higher the vertical development of a thunderstorm, the more intense it is, the stronger the updrafts and the downdrafts, and any precipitation, icing, hail, tornadic activity, etc. is going to be much higher in strength. We've got a couple more convective sigmets. This one here right on the edge of the Gulf, west-southwest at 30 knots. Tops are flight level 45,000. You'd want to remain at least 50 miles away from that one. So generally speaking, as a general aviation pilot, I'd probably want to stay far away from this weather system today and into the future as that moves farther east. There's also a small convective sigmet over West Virginia. Area of thunderstorms moving from the west-southwest at 20 knots. Tops are flight level 380. Now, the difference here is that these are not embedded. So when they're embedded, it's a thunderstorm that's also surrounded by clouds. That makes it a lot more difficult to see. When they're isolated thunderstorms, they're easier to see and therefore easier to avoid. It happens often in the summertime where you get those little isolated thunderstorms that are maybe, just 10, 15,000 feet tall. They're pretty easy to maneuver around as long as you are far away from them and you're not threading the needle. Threading the needle meaning that we're trying to go between two cells. So you want to maintain that radius from thunderstorms even when you're going between cells. What happens is we get something called an outflow boundary. So as the thunderstorm begins to go into the mature or even dissipating stage and you get massive downdrafts, when those downdrafts hit the earth, they go horizontally out. That can result in what we know as straight line winds that can do a bunch of damage, but typically, if the thunderstorm isn't particularly strong, it might not produce damage. Where it can be dangerous for us as pilots is if there are two thunderstorms that we're trying to fly between, and they're both in a similar stage where they're producing downdrafts and outflow boundaries. And where that air meets, that air that's coming together, there's only one way for it to go, which is up. When it meets and goes up vertically into the atmosphere, then we have the lifting action necessary to produce another thunderstorm. So the dissipation of these thunderstorms and their outflow boundaries can create another thunderstorm in and of itself, which is why we don't want to thread the needle. Alrighty, that's it for convective sigmets in the Gulf area and then a small one up in West Virginia. We'll look at airmets now. Okay, we got a lot of pretty colors, and for those who have been watching for a while, the prettier the map, the less likely I am to want to fly in it. So let's start with airmet Zulu. Northeast, we've got a couple Zulus. The freezing level in the northeast is ranging from 11,000 to 15,000 across the area. At the freezing level and above, there's a very good chance of moderate icing. Now, assuming no other hazards exist as general aviation pilots, we could stay in this area. We could stay below the freezing level, still be in a cloud, maintain terrain separation, and be safe. Here in that thunderstorm in the Gulf area, the freezing level ranges from 11,000 to about 17,000 feet. So moderate icing between 12,000 and flight level 250. So not only is there convective activity going on, but once we get high enough in the atmosphere, there is potential icing. Now, we already decided we're not going to fly in this area. In the northwest, I think it's going to be a different story. It's a little colder up there. Freezing level ranges from the surface to 14,000 feet across the area. So they anticipate moderate ice between the freezing level and 22,000 feet. This is one of those where you'd have to take a little bit closer look and see where the freezing level is where you are. Let's pull up Idaho County. It is 8 degrees on the surface. Meaning if we use a standard lapse rate, which very rarely is the lapse rate actually standard, it's just a good basis to kind of measure things. Standard lapse rate of 2 degrees per 1,000 feet, then you're at 4,000 AGL, well, by the time you get to the freezing level. And they've got a scattered layer at 4,500, overcast at 9,500. So by the time you're getting into a cloud, you are at or near the freezing level. In Bryce Canyon, very cold on the surface there too, 7 degrees. So again, about 4,000 feet, and there's a broken layer, there's a ceiling at 5,500, and weather's going to deteriorate. Holy moly, look at that. 210 at 29, gusting to 41 knots. That's a no-go for sure. So as far as icing is concerned, in the Gulf area, we already said we're not going to go there because of convective activity. In the northeast, potentially you could go there as long as you double-checked the freezing levels and made sure you were very aware of your outside air temperature. And we'll look at some other hazards here in a second. And the northeast, that would probably be a no-go for icing. So if you're going to be in a cloud, chances are you'll be at the freezing level or near it, which is a no-go because we don't have certification for a flight into known icing. Or if you do, you don't want to plan to use it. You want to have it available if you need it. So the differentiation there is FICI equipment, flight into known icing equipment, like Weeping Wings. That's used to get you out of a bad situation, not put you in one. Because there is a limitation for how long we can use that equipment, right? There's only so much juice you can carry in your airplane. Airmet Sierras. Airmet Sierras are for IFR conditions, which includes widespread areas of low ceilings or visibility and mountain obscuration. Mountain obscuration is IFR conditions over terrain. Flying over mountainous terrain can be a hazard in and of itself already in a piston engine. And then you add to that instrument conditions, and not only now is there terrain, but now you cannot see it, and it can be difficult to avoid something that you can't see. So that would definitely be a no-go situation for a VFR pilot, and it would should give an IFR pilot a second to pause and dive a little deeper into where they're going, what the procedures are, and if it fits their personal minimums. So up here where we had the icing airmet, we've got an airmet Sierra for IFR and for mountain obscuration caused by clouds, precipitation, or mist. Now, of course, where all that convective stuff is, we also have an airmet for IFR. We've got mountain obscuration over Colorado and New Mexico, and then mountain obscuration IFR up in the northeast. When we get to the point of there being an airmet Sierra for IFR conditions, that means it's a very large area. Whenever I'm flying IFR in a piston aircraft, I'm always trying to determine what are my outs, what are my alternates in case things go bad. And so if you're in an area of widespread instrument conditions, do you have an option for a safe place to go that meets your criteria and your level of currency and proficiency? If you're operating up here in the panhandle of Oklahoma, your options aren't super close. And there's really only so far we can go in a piston aircraft, comfortably at least, and then also consider if there's an emergency situation or defective equipment or sick passenger or something along those lines. I'm normally not keen on flying in an airmet Sierra, depending on just what exactly the ceilings are, and if the trend is that it's going to deteriorate or improve, and if that meets my personal minimums. Let's look now at airmet tangos. So generally speaking, the T is for turbulence. This also includes low-level wind shear, sustained surface winds of 30 knots or greater, which will probably be over here. We got low-level wind shear in the west, and sustained surface winds greater than 30 knots. So we got them both. Sustained surface winds, low-level turbulence, and we also have, looks like high-level turbulence up here as well. South California, Southern California, same thing, sustained surface winds, high-level turbulence, and low-level turbulence. That would be very uncomfortable for passengers over there. Across the central eastern U.S., we've got high-level turbulence. Now, as piston aircraft, this high-level turbulence doesn't particularly apply to us. because it starts at 18,000 or higher. However, it does give an overall indication of the stability of the atmosphere and what's going on. So if we know there's a widespread area of turbulence way far above us, that may lead us to think about what's going on down below or on the backside of whatever system is causing that. We also have low-level turbulence and low-level wind shear up in the northeast. So in the northeast, we had airmet Sierra for IFR and mountain obscuration. We've got an airmet Zulu for freezing and those airmet Tangos for low-level wind shear and low-level turbulence. Things are starting to not look so great for those up in the northeast. It's a similar story in the northwest. We've got icing, turbulence, low-level wind shear, sustained surface winds. It's probably not the best day to be flying in either of those areas. And then over in the Gulf Coast area, that huge convective stuff, that's the result of that cold front meeting that warm, moist air over the Gulf. That's definitely a no-go area for today. I did things a little backwards from the way we normally do it. But normally I look at the Metars first to kind of determine areas of IFR weather and VFR weather. But those areas track along with the Sigmets and airmets we already looked at. Generally speaking, the northeast up here is going to necessitate an instrument rating and an instrument flight plan. We see a lot of IFR, marginal VFR, and even some low IFR. Florida, Georgia, Alabama, and into Tennessee look mostly VFR for now. Beautiful VFR from Illinois and Wisconsin up over to Wyoming. St. Cloud, Minnesota, we've got winds light, 10 miles of visibility, and clear. Beautiful day and predicted to be that all day long. That's the kind of day where you get to solo for the first time. That's absolutely beautiful. We already know that Texas, Oklahoma, Kansas, Louisiana area is nasty, not only IFR, but lots of hazards associated with the weather in that area. Now, where it becomes a little bit harder for decision making is up here in the northeast. So we do see lots of VFR stations. So that means that, they're in the flight category of VFR. There's at least a 3,000 foot ceiling and 5 miles of visibility. However, we also know that there are quite a few airmets in that area. We've got icing, we've got IFR, we've got low-level turbulence, low-level wind shear, we've got sustained high surface winds. So that's an area where you would really want to take a moment to go a little bit deeper and figure out what's going on and is it safe to fly? Is it within my personal minimums? For example, let's pull up McCall, Idaho. So it's reporting IFR. Wind is pretty light, 150 at 6 knots, 8 miles of visibility, which fits the criteria for VFR. However, there's rain and overcast at 700. Now, of course, that would require an instrument rating in that area. And look, it's 2 degrees on the surface, which means that at just traffic pattern altitude, you could potentially expect to be in icing conditions. So that would be a no-go for me without certification for flight into known icing. Now, down in South California, we did see some airmets as well. Yeah, and that's supported by this Metar here at Daggett. Winds 270, 18 knots, gusting 30. Overcast at 4,100. So there's going to be low-level wind shear in that area, super strong surface winds, and predicted to get even worse before it does get slightly better. So that's going to be a no-go for me as well. That's a good day to fly a kite rather than an airplane. I will say here in central Kentucky, on the backside of these fronts that have come through, this would be perfect situation for getting some instrument currency and flying some instrument approaches. So here in Lexington, it's overcast at 1,200 feet. Wind is 250 at 5, 10 miles of visibility. It's nice and warm here on the surface. Freezing level is nowhere to be seen until we get way high up. And the ceilings are nice and high. They're marginal VFR, so they support getting up into the clouds, doing a little bit of instrument work, and doing some actual approaches and building some currency and instrument conditions. Supported by the fact that, it's marginal VFR, so the ceilings are not super low, and there are VFR areas scattered here and there. So Frankfurt here is scattered at 1900. scattered at 7,500. So technically VFR because the ceiling, well, there is no ceiling here, but there are some low clouds. So for all intents and purposes, it's actually kind of marginal. But this is a great day for shooting some actual approaches in actual conditions and building that currency and proficiency. Okay, so we looked at surface analysis, Sigmets, airmets. Let's look briefly at PIREPs. Looks like we do have some reports of turbulence. We've got several reports of turbulence in this area, even some icing. Little bit of icing up here in the northeast. It looks like for the most part, though, people are maybe avoiding this area. Some turbulence in Iowa. That's interesting. Quite a bit of turbulence over here in Colorado. And we've got some icing and turbulence up in the northeast. It's always a good idea to actually look at these PIREPs and see what kind of airplane it was, where they were, and then extrapolate or interpolate if that applies to you. Let's see up here in Indiana. 3,000 feet, SR-22 was reporting instrument conditions and light turbulence. And this one here's a DA-40, turbulent, light to moderate. Okay, so both of those are pretty small airplanes. It's very reasonable that if they're experiencing light to moderate turbulence, then it would also be light to moderate for you. However, if these were maybe a Boeing 737 at 3,000 feet on their climb out or descent and they were experiencing light turbulence, it's a fair chance that it's going to be a little bit more than light for us. So a lot of these PIREPs kind of support what we've already seen with airmets and Sigmets, the areas to avoid and the areas that are really nice. So, you know, the nicest day for weather today looks like it's going to be up in the central northern part of the country. We'll look briefly at cloud coverage. So we're going to click weather charts up at the top. We're going to go to cloud coverage here for CONUS for contiguous US. And this is only a forecast. It's not an observation. So we can only look into the future. And this supports everything that we've already talked about. We've got instrument conditions, south central US, northeast, and northwest. The only areas where there's VFR is up here in the northern part of the country, and then also Four Corners, but we know the Four Corners are also experiencing some of those airmet tangos for low-level wind shear and low-level turbulence. This is a great chart to choose your altitude for cruise, to determine if you'll be above clouds or below clouds, and then therefore, if you're going to be cruising in instrument conditions, or if you'll be able to maintain VFR cloud clearances if you're VFR only. Having an extended cruise in instrument conditions can be very tiring, especially if you don't have much automation in your airplane, so autopilot. So again, to support doing some instrument approaches here in the Kentucky, Illinois, Indiana, Ohio area, the tops of the clouds are really not high at all. So we've got in southern Indiana, overcast at 2,100, tops at 6,000. You could very easily get above that, do a nice cruise up to northern Indiana, and it's still marginal up there in Michigan with overcast ceilings at 1,800 and do an approach. Really great day, really great weather. No other hazards in the area associated with these clouds. It's a perfect day to do some instrument currency flying in this area. If you were doing an actual flight, you would absolutely want to check winds aloft to see at your chosen altitude how that's going to affect your time en route and therefore your fuel burn, and then determine if you'll need to get any stop for any fuel. And I'll just choose a nice, 7,000. Overall, it looks like the wind is pretty light on the east coast. Strongest I'm seeing is up here, probably 35 knots there. But overall, actually pretty light winds. No low-level jet streams really going on today. Here is a check ride question. Based on the wind barbs here in Oklahoma, Kansas, Texas, Louisiana area, what kind of weather system exists in this area? Well, you may remember from when we looked at the surface analysis earlier, a low pressure system exists in this area. Actually, a couple of them. So if you remember from meteorology class that the low pressure system, the air moves counterclockwise, inward, and upward, then you can apply that when you're looking at this winds aloft here. We see the wind is moving counterclockwise, somewhat inward, and then what we don't see is the vertical aspect of it, which is upward. We do see the results of that upward movement, though, in all of the convective activity here, stronger precipitation, and all of the cloud production. All right, we'll also look at the visibility surface precipitation chart. And this really supports everything that we've already talked about, right? We've got icing in the northwest. We've got some thunderstorms, actually, that are going to form in the northeast. And some, light chance of thunderstorms. Lots of precipitation, strong thunderstorms in the Gulf area, and lots of low visibility or ceilings, as indicated. We also see the surface winds here. So this supports everything else that we've looked at. We can go into the 6 hours, and we see the southeast is going to be covered in thunderstorms or potential for thunderstorms, which supports those convective outlooks. It's probably going to be yucky in the southeast today and later on. And the northeast as well, low visibilities. Northwest is going to be gross too. So we went through most of the pieces of this weather brief checklist. Of course, if you were doing an actual cross country, you would really want to spend quite a bit of time looking at this in depth. Weather plays a causal or contributing factor in far too many general aviation accidents. And if we take time to learn about the weather, understand it, and then understand how to make good decisions based on current conditions, then your likelihood for making it to your destination and also making it home will increase. Taking time to look at the weather and understand what's going on, even on days that you don't intend to fly, is going to be the best way to improve your comfort and decision-making ability with weather. As I look ahead at my week, there is going to be a lot of opportunity for ground instruction. I am Assistant Chief of a Part 141 flight school located here in Lexington. I also do some work independently as a flight instructor, both with owners and through some local flying clubs. If you're ever interested in receiving personalized flight training that's specific to you and your goals, please feel free to reach out on my website at gilbertaviation.com. If you're not in the Lexington area but would be interested in some virtual ground instruction, you can reach out to me there as well. There are quite a few areas across the country where we're going to be grounded for the next couple of days based on the weather. There are some areas that are going to look good for the next couple of days. So I'll ask you, what are you planning to do this week to contribute to aviation safety by making yourself a better pilot? Thanks so much for tuning in. We'll see you next time. Bye.